The Grandfather Paradox. You travel back in time and accidentally prevent your grandparents from meeting, which means your parents are never born, which means you are never born, which means you never traveled back in time, which means your grandparents do meet, which means you are born, which means you travel back in time again. The loop has no exit. You can't exist and not exist simultaneously. And yet the logic of the scenario demands both. This is the most famous time travel paradox, precisely because it's the simplest and no one has cleanly solved it. It doesn't just break causality, it breaks the basic rule that a thing cannot both be and not be at the same time. The Bootstrap Paradox. A musician travels back in time and teaches Beethoven his symphonies. Beethoven publishes them. Centuries later, the musician hears them, memorizes them, travels back, and teaches them to Beethoven. So, who actually composed the music? The information has no origin. It exists in a loop with no starting point. The Bootstrap Paradox, named after the phrase pulling yourself up by your own bootstraps, describes any situation where an object, piece of information, or event causes itself to exist. No creator, no beginning, just a loop that somehow already happened. The Predestination Paradox. You travel back in time to prevent a fire, but while you're there, you accidentally knock over a lamp and start the fire yourself. The event you tried to stop only happened because you went back to stop it. This is predestination, the idea that time travel doesn't change anything because everything that will happen has already happened, including your attempt to interfere. You were always part of the event. The timeline was always complete. Free will under this model is an illusion, not because someone controls you, but because the structure of time itself leaves no room for a different outcome. The butterfly effect. In 1963, mathematician Edward Lorenz discovered that tiny changes in initial conditions produce wildly different outcomes in complex systems. He described it as a butterfly flapping its wings in Brazil, setting off a tornado in Texas weeks later. Applied to time travel, the implication is extreme, going back even a few minutes and changing anything, stepping on a different patch of ground, saying one word differently, could cascade into changes so large that the future you came from no longer exists. The further back you go, the more catastrophic the divergence. Under this model, time travel isn't just dangerous, it's almost impossible to control even with perfect intentions. Time dilation. This one isn't theoretical, it's been measured. Einstein's theory of relativity shows that time moves slower for objects traveling at high speeds or in stronger gravitational fields. Astronauts on the International Space Station age slightly slower than people on Earth, about 0.007 seconds less per 6 months. GPS satellites have to correct for this constantly, or navigation would drift by miles per day. If you traveled at close to the speed of light for what felt like 1 year to you, decades could pass on Earth. You'd return younger than people who were born after you left. This is real, measurable time travel into the future, and it requires no paradox, no loop, and no science fiction, just speed. The Novikov self-consistency principle. Physicist Igor Novikov proposed a solution to most time travel paradoxes. The universe simply doesn't allow inconsistencies to happen. If you go back in time and try to kill your grandfather, something will always prevent it. You'll miss. The gun will jam. You'll have a change of heart, not because of fate in a mystical sense, but because any event that would create a paradox is assigned a probability of exactly zero by the laws of physics. The timeline protects itself. Only self-consistent events can occur, which means time travel is possible, but you can never actually change anything. You can only participate in what already happened. Many worlds, branching timelines. What if every time travel event, or every decision for that matter, creates a new branch of reality rather than altering the existing one? This is the many worlds interpretation, originally proposed in quantum mechanics by Hugh Everett in 1957. Applied to time travel, it dissolves most paradoxes entirely. You go back and prevent your grandparents from meeting, but you don't erase yourself. You've simply created a new branch where you don't exist, while the original branch where you do continues unchanged. There's no contradiction because there are now two separate timelines running in parallel. The cost of this solution is significant. It requires an infinite number of branching universes, each equally real. Closed timelike curves. In 1849, mathematician Kurt Gödel, a close friend of Einstein, used Einstein's own equations to prove that certain configurations of space-time could allow paths that loop back on themselves through time. He called them closed timelike curves. Traveling along one would mean moving forward through space and time continuously, but arriving back at your own starting point in the past. No paradox, no jump, no machine, just geometry. Gödel proved these solutions exist mathematically. Whether they exist physically depends on the structure of the universe, and we don't know yet if that structure permits them. The block universe. Most people experience time as flowing. The past is gone. The future doesn't exist yet. Only the present is real. Physics disagrees. Einstein's relativity suggests that past, present, and future all exist simultaneously in a four-dimensional structure called the block universe. Time doesn't flow, it simply is, all at once, and what we experience as the passage of time is just our consciousness moving through it like a needle through a record. Under this model, traveling to the past isn't going somewhere that no longer exists, it's going somewhere that always exists. The same way New York still exists when you're in Los Angeles. The past is a location, not a memory. The future is already there, waiting. The arrow of time. Everything in our experience moves in one direction, from past to future. Eggs break, but don't break. People age forward. Heat moves from hot to cold. But here's what physics actually says. Almost every fundamental law works equally well in both directions. Run the equations backward and they still hold. The one exception is entropy, the tendency of systems to move from order to disorder. The reason time feels like it has a direction is because the universe started in an extremely low entropy state at the Big Bang and has been moving toward greater disorder ever since. Time's arrow isn't built into the laws of physics. It's a consequence of where the universe started. If entropy could be reversed, if disorder could spontaneously become order, time itself might run backward. We have no evidence this is possible, but we also have no law that strictly forbids it.